guys, this is J Vignesh from Machine Learning. Today I have to explain about implementation of KMeans clustering for customer segmentation using elbow method. Let me consider a data frame which has to be converted as a data frame and giving parameter as a dictionary which has a age key and its value 19, 21, 20, 23 and annual income as a key and its value as a list 15, 20, 16, 18 as a LPA and the spending score as a key and its values in the list 39, 81, 677. To convert the dictionary into data frame, we want to import pandas library and we should keep it alias as pd and we are also importing from sklearn.cluster KMeans algorithm, importing matplotlib.pyplot as plt. We include the matplotlib library for data visualization and also importing sklearn.preprocessing, importing StandardScaler to standardizing the all features in a similar scale. Let consider a variable x and we converting the data frame which has in features age, annual income, spending score in x. We scaling we calling the standard scaler constructor and which has a object scaler and we transforming the x data frame into scaled x values and we defining a empty list wcss which means the within cluster sum of squared distance which is a sum of squared distance between cluster data points and its centroid. For k in range of 1 to 6, the range of 1 to 6 contains 1, 2, 3, 4 and 5. K means equal to k means of n cluster equal to k and random state equal to 42. We call in the k means constructor with object k mean and we have to split the data into 5 clusters. So n cluster equal to k volts value 1 to 5 and a random state of 42. K means dot fit, we want to train the model. So k means dot fit of training the model with the data set x and we appending the value of wcss, finding the squared distance between data point and centroid which is given by inertia underscore behavior. Inertia underscore is a attribute in KMeans and we appending it to wcss empty list and now we have to plot the elbow diagram. We have a figure which has a size of length 8 and breadth 5 and plotting the range of number of clusters range of 1 6 1 2 3 4 5 and versus wcss the squared distance between data points and centroid and which has a marker o plt.title. The title of the plot is elbow method. We have a xlabel as a number of clusters and ylabel as wcss. We plotting the plot between number of clusters and wcss which is a squared distance between data points and centroid. Plot, we want to show the plot, so plt.show of k means equal to k means of n clusters equal to 5 and a random state of 42. By using the elbow method, we can conclude that for at the optimal number of optimal number of cluster, we can split a best fit cluster. So we use a elbow method. For high value of number of clusters, we have a low value of wcss. As a number of clusters increase, the squared distance between the centroid decreases. Now we creating another feature in the data which is known as a cluster and which contains KMeans.fit predict x. We want to predict the clusters for age, annual income and spending score. We have to split the clusters into 5 for I in range of 5 which has 0, 1, 2, 3, 4. Cluster data equal to cluster data of, we want to find the records which has a cluster to be defined. Data of data cluster equal to I. For 0, I value 0, the cluster data equal to 0 which has the record in the data which has the values of annual income spending. So the final is to find the cluster data which has the labels age, annual income and spending. We want to scatter the cluster data. plt.scatter plot of cluster data of annual income, comma cluster data of spending score. We finding the cluster for annual income and spending score, and which to be label of cluster of high. So we want to scatter the data into clusters for both annual income and spending score. We as a title for the plot is customer segmentation, and X label as annual income, Y label as spending score, and calling the legend and showing our plot. So we now see the output of the program and in Jupyter notebook.